Hi there, what's up? Welcome back to Ecofunomics. I am Dr. Shreya Roy, the founder of Ecofunomics, and this is session 10 of data analytics using STATA or STATA, however you may pronounce it. Ecofunomics is registered under the Ministry of Corporate Affairs, Ministry of Education, Startup India, Scale India, and we are registered partner of IBM, that is IBM Plus. We are serving knowledge across 168 countries as of July 2025. I think that's about it. This is a registered certificate course being done online. In case you're interested in taking up the online course, all you need to do is click on the link down in the description box, register yourself, and learn at your own pace. When you're done learning, all you can do is let us know and we will send you your examination questions. All you have to do is answer it, and once you have cleared your examination, the certificate will be couriered to you or emailed to you. For more details, you may contact us at contact@ecofunomics.com or WhatsApp us on the number being displayed on your screen. In case you haven't watched our previous videos, I will link them in the iCard above. And we have also done a similar thing, that is, today we are learning linear regression, by the way. So today we are learning linear regression. We have also learned linear regression in SPSS. If you haven't watched that video, the link is again up in the iCard. I think that's about it. Now let's roll into the video, a little theoretical, brief up. Then we will enter into the software. Okay, so as you can see, this part, okay, so this is read as y is equal to beta naught plus x1 beta 1 plus x2 beta 2 dot xk beta k plus epsilon. Y is my dependent variable, beta naught is my intercept term, beta 1 is the coefficient of x1, all the x1, x2, xk, all the x's are your independent term, and associated beta is the associated coefficient of that respective independent term, and epsilon is your error term. So basically, what happens, beta naught tells you from where the equation is going to cut on the axis. If it is a negative, so it is going to cut on the negative part of your axis. And if it is positive, it is going to cut on the positive part. If beta 1 is positive, it means that x1 positively impacts y. So if beta 1 is positive, then you say as x increases, y also increases. On the other hand, if beta 1 is negative, then you say as x1 decreases, y1 increases. Opposite relations, okay? So beta, sign of beta determines the relationship between your independent variable and your dependent variable. There are various names for dependent variable, explained variable, response variable, predicted variable, whatever. And for independent variable, it is also called the explanatory variable, control variable, predictor variable, so on. Okay? These are your explanations. So the data that I'm using again is my profit, sales, advertisement, expenditure. So what I want to determine is whether the sales and advertisement expenditure have any impact on the profit of the respective companies. Okay, so what am I going to do? I'm going to write reg, which is the short form for regress. You can obviously write regress completely, but I'm writing reg. Then I'm selecting profit, sales, and advertisement expenditure. Please note, first you have to select your dependent variable or your y variable. Here, My dependent variable is profit. I want to see the impact of sales and advertisement expenditure on profit. So what am I saying? That sales and advertisement expenditure are my independent variables, where profit is my dependent variable. Also, if you haven't watched the previous videos, please go ahead and do that. And if you do not know how to import a data to STATA software, please, the link is up in the video is up in the iCard. Okay, just write reg, profit, sales, advertisement, and enter. So now the result that we get is there are total 25 number of observation. The F value is 177.45. It is significant. The R squared value is 0.9416. Adjusted R squared value is 0.9363. So which means that, it's a good fit. It's a good model, because the correlation is high. Okay. And let's come to the main regression, linear regression output table. So for sales, we see that the p-value is, okay, so your t-value is 4.38 and the probability of your p-value, probability greater than the t-value is 0.000. So which means it is very low than 0.05. Hence, it is significant, which means sales is affecting profit. How is it affecting profit? We look at the coefficient value. Since it is positive, we say sales is positively affecting profit. Let's take a look at advertisement expenditure. It is also significant at 99% confidence interval. Okay. So it is lesser than 0.05. Hence, we say it is significant and it is affecting profit. How is it affecting profit? It is affecting profit negatively since the associated coefficient is negative. So as advertisement expenditure increases, the profit decreases. So this is how you will write your answer. Okay. So our intercept value is just taking up to 3 decimal places. Okay. Making it 3 because there is 8 after that. Rounding off. Beta 1 is positive 0. So this also has to become positive and beta 1 becomes this. For your expenditure, it was advertisement expenditure actually. And the associated value is negative. And 2. So that is your answer. That is how you write it. Okay. So this will be your final answer. I hope you learned something new. If you have any doubts, please comment down below or write to us. If you want to join our certificate course, online certificate course, it's an easy process. Again, please get in touch. That's it. Please like, subscribe, and comment if you have anything additional to tell us. If you want us to make videos on some new software. Okay, that's about it. That's it for the STATA 101 course. We'll soon bring upgraded courses, a little advanced level courses. See you in the next video whenever I post that.